Hello, this is StuddyBuddy, a dialogue-based flashcarding system. I'm Lexie Krehbiel.
I'm Zach Rolston.
And I'm Spencer Hartwick. StuddyBuddy is a dialogue system designed to help users study flashcards in question and answer format. It reads flashcards to the user, assesses their answer, corrects them as necessary, and helps the user by giving hints and suggesting other topics of study based on proficiency. In order for the system to provide the best user experience, the system should be easy to use and work for varying session length, whether the user has a few minutes to study on the bus or wants to study for several hours. The system should also be designed to cater to auditory learners.
So I'm just going to go over a quick overview of our system. The user will speak to Google Assistant, which will transform their words into text through automatic speech recognition, passing the text along to Dialogflow for our natural language processing, which will then trigger certain intents and fulfillments in our backend on Firebase, written in Node.js. That will in turn send a set of strings as responses back to the user, or specifically back to Actions on Google, which will then read it out to the user as a text-to-speech. So I'll be covering the round-robin evaluation, but one of the things we did really well here was the answer keyword detection. Given a user's utterance, we were pretty easily able to pull out the specific keywords that were their intended answer. The only times these really didn't work out were when Google Assistant literally misheard the user. Just as well, the system was pretty easy to pick up. So by that I mean, after the user understood what was going on and understood what commands they could run with, all the dialogue flowed reasonably naturally and did well. So that sort of leads me into the flaws of our system. There were two main ones. The first being that the actual interactions that we had were not very clearly shown to the user. We did have reminders, but we tried to time these reminders pretty sparsely because we didn't want to annoy the user with consistent reminders of what things to do and what things they couldn't do. But this did backfire us in the end because, again, a lot of users weren't aware they could ask for hints, weren't aware they could skip cards, and occasionally this led to some misunderstandings, which was the much larger flaw that a lot of the times if we didn't handle something, it didn't go to a fallback intent, it instead was treated as an answer and actually repeated back to the user. This was probably a source of a lot of frustration and a lot of confusion in terms of where the users were in their conversations, and we actually cover that in the paper as a sample of bad dialogue and a few times where this was a catastrophic failure of an interaction. So we actually have a quick video demo of our good dialogue, and that's up next.
Sure, here's the test version of StuddyBuddy. Hi there, let's get learning. What deck would you like to study? I recommend studying movie trivia or advanced vocabulary.
I'll study movie trivia.
Alright then, switch to deck movie trivia. You will get a camera sticker for each correct answer. Here's your question. Who directed the 1994 crime thriller, Pulp Fiction?
Is it Quentin Tarantino?
Quentin Tarantino is just right. Woohoo. Onward. Answer this. What series gained a cult following in the 1990s, known for lampooning little-known, often poorly made B-movies?
What is my score?
You have earned 5 camera stickers. Here's the question again. What series gained a cult following in the 1990s, known for lampooning little-known, often poorly made B-movies?
I have no idea.
Alright, champ. We'll move past that one. The correct answer is Mystery Science Theater 3000. Here's your question. Who starred in the 1994 hit Forrest Gump?
Can I have a hint?
Maybe this will help. This actor was also known for playing Woody in Toy Story and talking to a volleyball named Wilson. What do you think the answer is?
I want to study something else.
Alright, what deck would you like to study? Let me know if you need them listed.
I'm done.
Now I'm going to go into our Paradise evaluation. For this, we chose 7 independent metrics, and those were distinct commands, repeated commands, number of interactions, successful deck switches, system response time, user response time, and length of system response. And more detailed explanations are given on this slide. We ran the multiple regression on this and then filtered out a couple of the independent variables that seemed to be kind of irrelevant based on either their p-value being high or their coefficient being really small. We found that 4 things appeared to be significant. The first of those things was distinct commands accessed. So if the user was able to access a lot of different commands, that was probably a successful interaction for the user. And that makes sense, right? Because they evidently had a good sense of what the system could do for them, and they were successful at accessing those different things that the system could do for them. After that, we saw user satisfaction versus repeated commands. If you look at this plot and you cut out the 2 outliers at the bottom left and the top right, you can see a negative correlation there. And that also makes sense, right? If you are repeatedly trying to use the same command, we can assume that as a user you were trying to do something and the system didn't do what you wanted. So we would expect to see a negative correlation there. Also, it's worth noting that these repeated commands exclude those that are just assessing a response, because that command should be repeated if you're repeatedly answering flashcards. The next thing we saw was user satisfaction versus length of system response. This was interesting to us because we saw a positive correlation here. So the longer the system response, the more satisfied the user was. We attribute this to longer system responses are longer explanations of what the system can do. So users that access these commands had a better sense of what the system could do for them and were therefore more satisfied. And then user satisfaction versus user response time also was correlated in a similar way, but we attribute this to the fact that those users who were accessing those long commands also had a long response time because we measured this from user response to user response. So really those 2 variables were conflated, and we think that user response time is really just more of a result of accessing those long commands. And that is all. Thank you.